File 13 of A Treatise of Human Nature by David Hume, Volume 1. This LibriVox recording is in the public domain. Read by George Yeager, Book 1, Part 2, Section 4, Objections Answered. Our system concerning space and time consists of two parts which are intimately connected together. The first depends on this chain of reasoning. The capacity of the mind is not infinite. Consequently, no idea of extension or duration consists of an infinite number of parts or inferior ideas, but of a finite number, and these simple and indivisible. It is therefore possible for space and time to exist conformable to this idea. And if it be possible, it is certain they actually do exist conformable to it, since their infinite divisibility is utterly impossible and contradictory. The other part of our system is a consequence of this. The parts into which the ideas of space and time resolve themselves become at last indivisible, and these indivisible parts, being nothing in themselves, are inconceivable when not filled with something real and existent. The ideas of space and time are therefore no separate or distinct ideas, but merely those of the manner or order in which objects exist. Or in other words, it is impossible to conceive either a vacuum and extension without matter, or a time when there was no succession or change in any real existence. The intimate connection betwixt these parts of our system is the reason why we shall examine together the objections which have been urged against both of them, beginning with those against the finite divisibility of extension. 1. The first of these objections, which I shall take notice of, is more proper to prove this connection and dependence of the one part upon the other, than to destroy either of them. It has often been maintained in the schools that extension must be divisible in infinitum, because the system of mathematical points is absurd, and that system is absurd because a mathematical point is a non-entity, and consequently can never by its conjunction with others form a real existence. This would be perfectly decisive were there no medium betwixt the infinite divisibility of matter and the non-entity of mathematical points. But there is evidently a medium. That is, the bestowing a color or solidity on these points, and the absurdity of both the extremes is a demonstration of the truth and reality of this medium. The system of physical points, which is another medium, is too absurd to need a refutation. A real extension, such as a physical point is supposed to be, can never exist without parts different from each other, and wherever objects are different, they are distinguishable and separable by the imagination. 2. The second objection is derived from the necessity there would be of penetration if extension consisted of mathematical points. A simple and indivisible atom that touches another must necessarily penetrate it, for it is impossible it can touch it by its external parts, from the very supposition of its perfect simplicity, which excludes all parts. It must therefore touch it intimately and in its whole essence, secundum se tota et totaliter, which is the very definition of penetration. But penetration is impossible. Mathematical points are of consequence equally impossible. I answer this objection by substituting a juster idea of penetration. Suppose two bodies containing no void within their circumference to approach each other, and to unite in such a manner that the body which results from their union is no more extended than either of them. It is this we must mean when we talk of penetration. But it is evident this penetration is nothing but the annihilation of one of these bodies, and the preservation of the other, without our being able to distinguish particularly which is preserved and which annihilated. Before the approach we have the idea of two bodies. After it we have the idea only of one. It is impossible for the mind to preserve any notion of difference betwixt two bodies of the same nature existing in the same place at the same time. Taking, then, penetration in this sense for the annihilation of one body upon its approach to another, I ask any one if he sees a necessity that a colored or tangible point should be annihilated upon the approach of another colored or tangible point. On the contrary, does he not evidently perceive that from the union of these points there results an object which is compounded and divisible, and may be distinguished into two parts, of which each preserves its existence distinct and separate, notwithstanding its contiguity to the other? Let him aid his fancy by conceiving these points to be of different colors, the better to prevent their coalition and confusion. A blue and a red point may surely lie contiguous without any penetration or annihilation, for if they cannot, what possibly can become of them? Whether shall the red or the blue be annihilated? Or if these colors unite into one, what new color will they produce by their union? What chiefly gives rise to these objections, and at the same time renders it so difficult to give a satisfactory answer to them, is the natural infirmity and unsteadiness both of our imagination and senses when employed on such minute objects. Put a spot of ink upon paper, and retire to such a distance that the spot becomes altogether invisible. You will find that upon your return and nearer approach, the spot first becomes visible by short intervals, and afterwards becomes always visible, and afterwards acquires only a new force in its coloring without augmenting its bulk, and afterwards, when it has increased to such a degree as to be really extended, it is still difficult for the imagination to break it into its component parts, because of the uneasiness it finds in the conception of such a minute object as a single point. This infirmity affects most of our reasonings on the present subject, and makes it almost impossible to answer in an intelligible manner, and in proper expressions, many questions which may arise concerning it. 3. There have been many objections drawn from the mathematics against the indivisibility of the parts of extension, though at first sight that science seems rather favorable to the present doctrine, and if it be contrary in its demonstrations, it is perfectly conformable in its definitions. My present business, then, must be to defend the definitions and refute the demonstrations. A surface is defined to be length and breadth without depth. A line to be length without breadth or depth. A point to be what has neither length, breadth, nor depth. It is evident that all this is perfectly unintelligible upon any other supposition than that of the composition of extension by indivisible points or atoms. How else could anything exist without length, without breadth, or without depth? Two different answers, I find, have been made to this argument, neither of which is, in my opinion, satisfactory. The first is, that the objects of geometry those surfaces, lines, and points whose proportions and positions it examines are mere ideas in the mind, and not only never did, but never can exist in nature. They never did exist, for no one will pretend to draw a line or make a surface entirely conformable to the definition. They never can exist, for we may produce demonstrations from these very ideas to prove that they are impossible. But can anything be imagined more absurd and contradictory than this reasoning? Whatever can be conceived by a clear and distinct idea necessarily implies the possibility of existence, and he who pretends to prove the impossibility of its existence by any argument derived from the clear idea, in reality asserts that we have no clear idea of it, because we have a clear idea. It is in vain to search for a contradiction in anything that is distinctly conceived by the mind. Did it imply any contradiction, it is impossible it could ever be conceived. There is therefore no medium betwixt allowing at least the possibility of indivisible points and denying their idea, and it is on this latter principle that the second answer to the foregoing argument is founded. It has been pretended, Lord de Pensée, that though it be impossible to conceive a length without any breadth, yet by an abstraction without a separation we can consider the one without regarding the other, in the same manner as we may think of the length of the way betwixt two towns and overlook its breadth. The length is inseparable from the breadth, both in nature and in our minds, but this excludes not a partial consideration and a distinction of reason after the manner above explained. In refuting this answer, I shall not insist on the argument which I have already sufficiently explained, that if it be impossible for the mind to arrive at a minimum in its ideas, its capacity must be infinite in order to comprehend the infinite number of parts of which its idea of any extension would be composed. I shall here endeavour to find some new absurdities in this reasoning. A surface terminates a solid. A line terminates a surface. A point terminates a line. But I assert that if the ideas of a point, line, or surface were not indivisible, it is impossible we should ever conceive these terminations. For let these ideas be supposed infinitely divisible, and then let the fancy endeavour to fix itself on the idea of the last surface, line, or point. It immediately finds this idea to break into parts, and upon its seizing the last of these parts, it loses its hold by a new division, and so on in infinitum, without any possibility of its arriving at a concluding idea. The number of fractions bring it no nearer the last division than the first idea it formed. Every particle eludes the grasp by a new fraction, like quicksilver, when we endeavour to seize it. But as in fact there must be something which terminates the idea of every finite quantity, and as this terminating idea cannot itself consist of parts or inferior ideas, otherwise it would be the last of its parts, which finish the idea, and so on, this is a clear proof that the ideas of surfaces, lines, and points admit not of any division. Those of surfaces in depth, of lines in breadth and depth, and of points in any dimension. The schoolmen were so sensible of the force of this argument, that some of them maintained that nature has mixed among those particles of matter which are divisible in infinitum a number of mathematical points in order to give a termination to bodies. and others eluded the force of this reasoning by a heap of unintelligible cavils and distinctions. Both these adversaries equally yield the victory. A man who hides himself confesses as evidently the superiority of his enemy as another who fairly delivers his arms. Thus it appears that the definitions of mathematics destroy the pretended demonstrations, and that if we have the idea of indivisible points, lines, and surfaces conformable to the definition, their existence is certainly possible. But if we have no such idea, it is impossible we can ever conceive the termination of any figure, without which conception there can be no geometrical demonstration. But I go farther and maintain that none of these demonstrations can have sufficient weight to establish such a principle as this of infinite divisibility, and that because with regard to such minute objects they are not properly demonstrations, being built on ideas which are not exact, and maxims which are not precisely true. When geometry decides anything concerning the proportions of quantity, we ought not to look for the utmost precision and exactness. None of its proofs extends so far. It takes the dimensions and proportions of figures justly, but roughly, and with some liberty. Its errors are never considerable, nor would it err at all, did it not aspire to such an absolute perfection. I first ask mathematicians what they mean when they say one line or surface is equal to, or greater, or less than another. Let any of them give an answer to whatever sect he belongs, and whether he maintains the composition of extension by indivisible points, or by quantities divisible in infinitum. This question will embarrass both of them. There are few or no mathematicians who defend the hypothesis of indivisible points, and yet these have the readiest and justest answer to the present question. They need only reply that lines or surfaces are equal when the numbers of points in each are equal, and that as the proportion of the numbers varies, the proportion of the lines and surfaces is also varied. But though this answer be just as well as obvious, yet I may affirm that this standard of equality is entirely useless, and that it never is from such a comparison we determine objects to be equal or unequal with respect to each other. For as the points which enter into the composition of any line or surface, whether perceived by the sight or touch, are so minute and so confounded with each other, that it is utterly impossible for the mind to compute their number, such a computation will never afford us a standard by which we may judge of proportions. No one will ever be able to determine by an exact numeration that an inch has fewer points than a foot, or a foot fewer than an ell, or any greater measure, for which reason we seldom or never consider this as the standard of equality or inequality. As to those who imagine that extension is divisible in infinitum, it is impossible they can make use of this answer, or fix the equality of any line or surface by enumeration of its component parts. For since, according to their hypothesis, the least as well as greatest figures contain an infinite number of parts, and since infinite numbers, properly speaking, can neither be equal nor unequal with respect to each other, the equality or inequality of any portions of space can never depend on any proportion in the number of their parts. It is true, it may be said, that the inequality of an ell and a yard consists in the different numbers of the feet of which they are composed, and that of a foot and a yard in the number of the inches. But as that quantity we call an inch in the one is supposed equal to what we call an inch in the other, and as it is impossible for the mind to find this equality by proceeding in infinitum with these references to inferior quantities, it is evident that at last we must fix some standard of equality different from an enumeration of the parts. There are some, see Dr. Barrow's Mathematical Lectures, who pretend that equality is best defined by congruity, and that any two figures are equal when upon the placing of one upon the other all their parts correspond to and touch each other. In order to judge of this definition, let us consider that since equality is a relation, it is not, strictly speaking, a property in the figures themselves, but arises merely from the comparison which the mind makes betwixt them. If it consists therefore in this imaginary application and mutual contact of parts, we must at least have a distinct notion of these parts, and must conceive their contact. Now it is plain that in this conception we would run up these parts to the greatest minuteness which can possibly be conceived, since the contact of large parts would never render the figures equal. But the minutest parts we can conceive are mathematical points, and consequently this standard of equality is the same with that derived from the equality of the number of points, which we have already determined to be a just, but an useless standard. We must therefore look to some other quarter for a solution of the present difficulty. There are many philosophers who refuse to assign any standard of equality, but assert that it is sufficient to present two objects that are equal in order to give us a just notion of this proportion. All definitions, say they, are fruitless without the perception of such objects, and where we perceive such objects we no longer stand in need of any definition. To this reasoning I entirely agree, and assert that the only useful notion of equality or inequality is derived from the whole united appearance and the comparison of particular objects. It is evident that the eye, or rather the mind, is often able at one view to determine the proportions of bodies and pronounce them equal to, or greater, or less than each other, without examining or comparing the number of their minute parts. Such judgments are not only common, but in many cases certain and infallible. When the measure of a yard and that of a foot are presented, the mind can no more question that the first is longer than the second, than it can doubt of those principles which are the most clear and self-evident. There are therefore three proportions which the mind distinguishes in the general appearance of its objects, and calls by the names of greater, less, and equal. But though its decisions concerning these proportions be sometimes infallible, they are not always so, nor are our judgments of this kind more exempt from doubt and error than those on any other subject. We frequently correct our first opinion by a review and reflection, and pronounce those objects to be equal, which at first we esteemed unequal, and regard an object as less, though before it appeared greater than another. Nor is this the only correction which these judgments of our senses undergo, but we often discover our error by a juxtaposition of the objects, or, where that is impracticable, by the use of some common and invariable measure, which, being successively applied to each, informs us of their different proportions. And even this correction is susceptible of a new correction, and of different degrees of exactness, according to the nature of the instrument by which we measure the bodies, and the care which we employ in the comparison. When, therefore, the mind is accustomed to these judgments and their corrections, and finds that the same proportion which makes two figures have in the eye that appearance which we call equality, makes them also correspond to each other, and to any common measure with which they are compared, we form a mixed notion of equality, derived both from the looser and stricter methods of comparison. But we are not content with this; for as sound reason convinces us that there are bodies vastly more minute than those which appear to the senses, and as a false reason would persuade us that there are bodies infinitely more minute, we clearly perceive that we are not possessed of any instrument or art of measuring, which can secure us from all error and uncertainty. We are sensible that the addition or removal of one of these minute parts is not discernible either in the appearance or measuring; and as we imagine that two figures which were equal before cannot be equal after this removal or addition, we therefore suppose some imaginary standard of equality, by which the appearances and measuring are exactly corrected, and the figures reduced entirely to that proportion. This standard is plainly imaginary; for as the very idea of equality is that of such a particular appearance corrected by juxtaposition or a common measure, the notion of any correction beyond what we have instruments and art to make is a mere fiction of the mind, and useless as well as incomprehensible. But though this standard be only imaginary, the fiction, however, is very natural; nor is anything more usual than for the mind to proceed after this manner with any action, even after the reason has ceased which first determined it to begin. This appears very conspicuously with regard to time, where, though it is evident we have no exact method of determining the proportions of parts, not even so exact as in extension, yet the various corrections of our measures and their different degrees of exactness have given us an obscure and implicit notion of a perfect and entire equality. The case is the same in many other subjects. A musician, finding his ear becoming every day more delicate, and correcting himself by reflection and attention, proceeds with the same act of the mind, even when the subject fails him, and entertains a notion of a complete tierce or octave, without being able to tell whence he derives his standard. A painter forms the same fiction with regard to colours; a mechanic with regard to motion. To the one light and shade, to the other swift and slow, are imagined to be capable of an exact comparison and equality beyond the judgments of the senses. We may apply the same reasoning to curve and right lines. Nothing is more apparent to the senses than the distinction betwixt a curve and a right line, nor are there any ideas we more easily form than the ideas of these objects. But however easily we may form these ideas, it is impossible to produce any definition of them which will fix the precise boundaries betwixt them. When we draw lines upon paper, or any continued surface, there is a certain order by which the lines run along from one point to another, that they may produce the entire impression of a curve or right line. But this order is perfectly unknown, and nothing is observed but the united appearance. Thus, even upon the system of indivisible points, we can only form a distant notion of some unknown standard to these objects. Upon that of infinite divisibility, we cannot go even this length, but are reduced merely to the general appearance, as the rule by which we determine lines to be either curve or right ones. But though we can give no perfect definition of these lines, nor produce any very exact method of distinguishing the one from the other, yet this hinders us not from correcting the first appearance by a more accurate consideration, and by a comparison with some rule of whose rectitude from repeated trials we have a greater assurance. And it is from these corrections, and by carrying on the same action of the mind, even when its reason fails us, that we form the loose idea of a perfect standard to these figures without being able to explain or comprehend it. It is true, mathematicians pretend they give an exact definition of a right line when they say it is the shortest way betwixt 2 points. But in the first place, I observe that this is more properly the discovery of one of the properties of a right line than a just definition of it. For I ask any one, if upon mention of a right line he thinks not immediately on such a particular appearance, and if it is not by accident only that he considers this property. A right line can be comprehended alone, but this definition is unintelligible without a comparison with other lines, which we conceive to be more extended. In common life, it is established as a maxim, that the straightest way is always the shortest, which would be as absurd as to say, the shortest way is always the shortest, if our idea of a right line was not different from that of the shortest way betwixt 2 points. Secondly, I repeat what I have already established, that we have no precise idea of equality and inequality, shorter and longer, more than of a right line or a curve, and consequently that the one can never afford us a perfect standard for the other. An exact idea can never be built on such as are loose and undeterminate. The idea of a plane surface is as little susceptible of a precise standard as that of a right line, nor have we any other means of distinguishing such a surface than its general appearance. It is in vain that mathematicians represent a plane surface as produced by the flowing of a right line. It will immediately be objected that our idea of a surface is as independent of this method of forming a surface as our idea of an ellipse is of that of a cone, that the idea of a right line is no more precise than that of a plane surface, that a right line may flow irregularly, and by that means form a figure quite different from a plane, and that therefore we must suppose it to flow along 2 right lines parallel to each other and on the same plane, which is a description that explains a thing by itself and returns in a circle. It appears then that the ideas which are most essential to geometry, that is, those of equality and inequality, of a right line and a plane surface, are far from being exact and determinate according to our common method of conceiving them. Not only we are incapable of telling if the case be in any degree doubtful when such particular figures are equal, when such a line is a right one, and such a surface a plane one, but we can form no idea of that proportion, or of these figures, which is firm and invariable. Our appeal is still to the weak and fallible judgment, which we make from the appearance of the objects, and correct by a compass or common measure. And if we join the supposition of any farther correction, it is of such a one as is either useless or imaginary. In vain should we have recourse to the common topic and employ the supposition of a deity, whose omnipotence may enable him to form a perfect geometrical figure and describe a right line without any curve or inflection. As the ultimate standard of these figures is derived from nothing but the senses and imagination, it is absurd to talk of any perfection beyond what these faculties can judge of, since the true perfection of any thing consists in its conformity to its standard. Now, since these ideas are so loose and uncertain, I would fain ask any mathematician what infallible assurance he has, not only of the more intricate and obscure propositions of his science, but of the most vulgar and obvious principles. How can he prove to me, for instance, that two right lines cannot have one common segment, or that it is impossible to draw more than one right line betwixt any two points? Should he tell me that these opinions are obviously absurd and repugnant to our clear ideas, I would answer, that I do not deny, where two right lines incline upon each other with a sensible angle, but it is absurd to imagine them to have a common segment. But supposing these two lines to approach at the rate of an inch in 20 leagues, I perceive no absurdity in asserting that upon their contact they become one. For I beseech you, by what rule or standard do you judge when you assert that the line in which I have supposed them to concur cannot make the same right line with those two that form so small an angle betwixt them? You must surely have some idea of a right line to which this line does not agree. Do you therefore mean that it takes not the points in the same order, and by the same rule, as is peculiar and essential to a right line? If so, I must inform you that besides that in judging after this manner you allow that extension is composed of indivisible points, which perhaps is more than you intend, besides this, I say, I must inform you that neither is this the standard from which we form the idea of a right line, nor, if it were, is there any such firmness in our senses or imagination as to determine when such an order is violated or preserved. The original standard of a right line is in reality nothing but a certain general appearance, and it is evident right lines may be made to concur with each other, and yet correspond to this standard, though corrected by all the means either practicable or imaginable. To whatever side mathematicians turn, this dilemma still meets them. If they judge of equality or any other proportion by the accurate and exact standard, that is, the enumeration of the minute indivisible parts, they both employ a standard which is useless in practice, and actually establish the indivisibility of extension, which they endeavour to explode. Or, if they employ, as is usual, the inaccurate standard, derived from a comparison of objects upon their general appearance, corrected by measuring and juxtaposition, their first principles, though certain and infallible, are too coarse to afford any such subtle inferences as they commonly draw from them. The first principles are founded on the imagination and senses. The conclusion, therefore, can never go beyond, much less contradict these faculties. This may open our eyes a little, and let us see that no geometrical demonstration for the infinite divisibility of extension can have so much force as what we naturally attribute to every argument which is supported by such magnificent pretensions. At the same time we may learn the reason why geometry fails of evidence in this single point, while all its other reasonings command our fullest assent and approbation. and indeed it seems more requisite to give the reason of this exception than to shew that we really must make such an exception, and regard all the mathematical arguments for infinite divisibility as utterly sophistical. For it is evident that as no idea of quantity is infinitely divisible, there cannot be imagined a more glaring absurdity than to endeavour to prove that quantity itself admits of such a division, and to prove this by means of ideas which are directly opposite in that particular. And as this absurdity is very glaring in itself, so there is no argument founded on it which is not attended with a new absurdity, and involves not an evident contradiction. I might give as instances those arguments for infinite divisibility which are derived from the point of contact. I know there is no mathematician who will not refuse to be judged by the diagrams he describes upon paper, these being loose draughts, as he will tell us, and serving only to convey with greater facility certain ideas which are the true foundation of all our reasoning. This I am satisfied with, and am willing to rest the controversy merely upon these ideas. I desire, therefore, our mathematician to form as accurately as possible the ideas of a circle and a right line, and I then ask if upon the conception of their contact he can conceive them as touching in a mathematical point, or if he must necessarily imagine them to concur for some space. Whichever side he chooses, he runs himself into equal difficulties. If he affirms that in tracing these figures in his imagination he can imagine them to touch only in a point, he allows the possibility of that idea, and consequently of the thing. If he says that in his conception of the contact of those lines he must make them concur, he thereby acknowledges the fallacy of geometrical demonstrations when carried beyond a certain degree of minuteness, since it is certain he has such demonstrations against the concurrence of a circle and a right line, that is, in other words, he can prove an idea, that is, that of concurrence, to be incompatible with two other ideas, that is, those of a circle and right line, though at the same time he acknowledges these ideas to be inseparable. End of File 13.